So this is the output, guys. After showing you this output, I will show you how I created this streamline application, right? So these are the car brands, guys. Reds, Wagoner, and Shift, Alto. Every attribute, every category we got in our dataset is listed here. Fortuner. Like that, we have to select any of that value. And the manufacturer years. This is also in the range of our dataset, guys, 2007 to 2014, right? Let me select a year, 2009. A number of kilometers driven, guys. So if you observe this, 500 to 5 lakhs. Let's take it as 1,20,000, something like that, 21,000. Let's take it as petrol only. Fuel type and seller type is a dealer, and transmission type is manual. And the owner, it is the first owner. So let's take the current present price as 4 lakhs, guys, and then predict it. So if you see, the predicted selling car price is around 64,315, right, guys? So if you see here, we can change the year to 2010. Then it is the latest car rate, better than 2009. Then it should be 1 lakh, right? And if it is 2011, then it should be more than 1 lakh, right? 1,49,000, like that. So if it is less kilometers driven, it should be 1,63,000, right, guys? So if it is more kilometers driven, then the price should be less, right? So 67,000, because it is driven, it is used many times, right? So that's why the price is fluctuating like that. So based on these values, we can predict our selling car price here. So let me show you how we created this web app, right? Hello guys, welcome back to KRecord. I'm back with another interesting project video, that is car price prediction. In this video, we will discuss about predicting the car price using different features, right? So let's see the attributes of the dataset we have taken here, right, guys? First, we have to see the dataset. So here are the attributes we took from dataset version 1. There are 4 other versions for this dataset also, but we will discuss about version 1 and we will create a model using this dataset version 1. For the rest of the versions, we will make separate video, so stay tuned. So coming back to the attributes, guys, here the first one is the car name is nothing but the brand of the car, and here it got manufactured, and selling price is what the target value is, target variable, which we are going to predict using all other attributes here. So the present price of the car and kilometers driven by the car, fuel type of the car, like whether it is diesel, petrol, CNG, like that, and seller type, whether it is a dealer or the individual itself selling the car, right? And transmission is nothing but the gearing system of the car, whether it is manual or automatic. There are only 2 categories. And owner might be the first owner or the second owner, like that. The value will be 0 if the owner is the first owner of the car, and it will be 1 if the owner is second owner of the car. Like if it is first hand car, then the owner value will be 1. If it is a like fresh car he bought, then it will be 0. If it is second hand car, then the value will be 2. Like that, the value goes on, guys, right? So I've explained about all these attributes. After creating the model for this car price prediction, guys, we'll be also making the web app to give the inputs from the UI and click a button, predict, and we'll be knowing the price of the car within no time, right, guys? So we'll do that using Streamlit. Let's see that in the same video here again at the last. So watch till the end, guys, so you'll get more information and you can also know about a web app. So now let's go ahead and create the Jupyter notebook and let's do it, guys. So I'm back here on Jupyter Labs again. Let's create a Jupyter notebook here. So I'm creating a notebook. Let's rename it car price prediction, right? So the first step is to import the dataset, right? So to import the dataset, I have to use pandas. So let's import the pandas first and then dataset next. So import pandas as PD, and then we have to import our dataset, right? So we use .read CSV function to read the dataset, right, guys? .car data, like that, and I will be storing it in car data, like that. Let's see the first few rows of this dataset using .head function. Let's run it, guys. Okay, I missed it. .csv. Let's run it again. Yeah, here's the output, guys. So if you observe this dataset, I've explained about all the attributes earlier in this video, like the car name, year, selling price, present price, kilometers driven, fuel type, seller type, transmission, and then owner. So let's see the shape of this dataset, guys. So if you see, there are 301 rows and 9 columns, guys. In these 9 columns, we have to predict the selling price of the car using all other 8 columns, right? So let's also see the data type of all the attributes, guys. We can use .info method, .info, to know all the types of the dataset, the variables, right? So the car name, it is object, year, selling price, and present price, they are the numerical values, right? And kilometer driven is also the numerical value, and fuel type, seller type, transmission are objects because they are categorical values, and owner is nothing but 0, 1, 2, 3, like that, so it is an integer value again. So let's see if there are any null values in the dataset, guys. We can do that using isNull function, right? So car data dot is null, right? So it checks whether the value is null or not, right? So if you see here, the false, 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 somewhere there will be some true values where if there is any null values present in the dataset, right guys? So we can get the count for each and every attribute using dot sum. So if you see here, there are no true values, that means there are no null values in our dataset, right guys? So let's check for the duplicate values again. The duplicate values are nothing but the same rows, the identical rows repeating again and again in the dataset. So we have to remove those identical values because they are duplicated 1 or 2 times. So let's see how many duplicate values are present in our dataset. Car dataset dot, we have duplicated function, so it will return the same false, 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 true, 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 like that. And then we have to use dot sum. So these are all the rows of our dataset, guys. So there might be true values here somewhere if there are 2 identical rows present in the dataset, right guys? So dot sum will gives us the number of rows that are duplicated. So there are 2 rows that are duplicated, 2 rows which are identical, we can say like that. Then we can drop 1 row of these 2 rows to make it unique, right guys? So we can also see what are all those rows which are having identical values, guys. So let's take car data. I'm taking car data and I have to find the duplicated values only, right guys? So I'm taking this, and if it is equal to true, then I have to take the data. So these are 2 values which are identical here. So for 17, row 17, there is one more identical row which is of same type, Etika 2016 7.75, and these are all values will be same in the another row. Let's see that row also again. Car data. Let's filter out all these variables equal to Etika. So if you see here, 2016 is repeating 2 times. Row 15, which is identical to row 17, right guys? So in this 2, 15 and 17, we have to remove 1 row, that is nothing but this is removing the 17th one, right? And in the same way, Fortuner, let's check for Fortuner. So 93, this is one column, 93, and there will be another column which is identical to 93. So if you see 51, it is very identical to 93, right? So the both rows are same, 93 and 51, right guys? So in these 2 identical columns, we will remove 93 row. So that's how it works, guys. So there is one more function to drop the duplicate rows in the dataset. That is nothing but car data dot drop duplicates, right guys? If you use this function, it will drop all the duplicate rows, and we have to assign these to the same car data variable, right guys? Let's also check the car data shape now. So it should be 301 minus 2, that is 299, right guys? So 299 rows with 9 columns again, right? So we have successfully dropped the duplicate values in our dataset. Let's see the statistical values for our dataset, guys, like mean, standard deviation, minimum value, and maximum value, all of those. We can see all those values using dot describe function. So car data dot describe will give me all the data. So if you see year, selling price, present price, kilometers driven, and owner. If you observe, these are all the numerical values. So for categorical values, we cannot find all these mean, standard deviation, minimum, maximum value, right guys? Because this will be apt to only the numerical values. So if you see all of them, there are no some odd values here, I guess. So everything is pretty much fine. So we have observed the statistical values for the numerical values, but what about categorical values? We can see them visually to analyze how many categories are there and how many number of rows comes under different categories, right guys? So for that, I'm importing matplotlib .py plot as plt, and also cbon import cbon as sns, right guys? Oh, I missed p. Okay, so I'm importing the matplotlib and cbon, guys, here. So after importing, I want to plot it for all the categorical values, guys. So there are how many categorical values? If you observe 1 2 3 4 categorical values, so I have to repeat the code again and again. Instead of that, I can simply write a function which plot the data for our categorical values, right guys? So let's define plot data function which takes the data as usual and the column name like that, and might be column type, because based on type only, object type only I want to plot, right? So if column type is equal to object, then only I want to plot the graph, right? So I'm defining a figure size here, plot dot figure of figure size is equal to 5,3, like that. Yes, and then let's plot the count plot for these different categorical values, because count plot gives us all the number of values in that separate category for every attribute, right? So sns dot count plot, you have to give the column name and the data equal to is nothing but data, and taking it as data only. And let's give some color coding here like ylgn B. So yellow, green, blue. We can say that. And then we have to plot it. plt dot show. So this gives us the plot for all our variables. Let's use a for loop to call this function. For I in data dot columns, right? This data dot columns gives us all the data variables names, right? If I want to print it, let's see. Oh, this is car data. So these are all the variables I have in our data set. So let's call this plot data, right? Plot data. And then we have to send the data. Data is nothing but the car data. You can send the whole data, and then I is the column name, and the data type is nothing but car data dot d type. Like that we can do that to get the object type or numeric type, whatever it is. It will give the type of the variable, like object, float, integer, like that. Whatever the value we have seen earlier here, the d type. This is a d type, right? So it will give all these values. So I'm comparing with object type. The same thing I'm retrieving here, and I'm comparing it here in this function and plotting accordingly, right? So let's call it. So for car name, these are many brands, I guess. So it is showing like this on x-axis. Let's come to this again, and if you see here, selling price, present price, kilometers driven, or the numeric values. So there is no graph for that. And fuel type, if you see here, petrol category is having so many rows, and diesel is having little bit less rows, and then CNG is having very minute number of rows in this data set, right? And seller type, there are more dealers than individuals, right? And transmission, there are more manual cars than automatic cars. We can see these are the analysis we can do from these graphs. And coming back to the car name, let's see how many car names are present in our dataset, right? So car data dot car name dot unique, which will give us all the unique names, right? So if you observe here, there is Bajaj Pulsar 150, Bajaj Avenger 220, but both comes under Bajaj, right? And Honda CBR 150 and Honda CB Twister, right? And Hero Glamour, Hero Super Splendor, all comes under same company, but they had different names, right? But the starting name of that all the attributes are same. So let's do some pre-processing here to get the starting name of all the cars, right? Only Royal, like that, Royal Enfield or Royal, and KTM, Bajaj, and Hero, Honda, like that we have to take the first value. Here it is TVS, right? So like that, let's take all these values. So to take only the first value, I can do this, right, guys? If there is one value x, what can I do? I can do x dot split it space, and I have to take the first value, right, guys? So I can define a lambda function here like this and retrieve the first value, right, guys? So like this, and let me name this lambda function as brand, like that. So this brand gives me the first value of the car name, right? So let me show you car data of car price, car name dot apply of brand. Dot apply is a function where it applies the function to each and every row, right, guys? So let's see the data. Car name, I guess it is capital N. Yes, it is capital N. So if you see here, and let's see the unique values dot unique. So if you see here, these are very less than all these values, right? Because we only took the first value, which is the company name of that specific car, right? So let's assign it to the car name attribute. So we are taking the first value of the car name, that is the company name, and we are assigning it back to the same variable, like this. So now if I draw this graph again, let's see, we can see the difference. So if you see, there are less number of categories than this graph, right? So we can't see this. If this graph is more elaborated, we can see all of them. Let's try that. So if you see, there is no space here, but yeah, we can see there are a few of the categories clearly. Yeah, these are the categories which are having in this car name. So we did pre-processing on car name, and we have seen other categories in all the object attributes, and we also seen the statistic summary of all the attributes, right? Now let's pre-process these categorical values like manual, automatic, and all these columns into numerical values, right? For that we can use either manual method, or we can use the predefined function, that is label encoder from sklearn, right? So I'm using label encoder only. So instead of having the manual work, I can do that. So let's import label encoder from sklearn. So from sklearn, import pre-processing. So from this pre-processing, we have to import the label encoder. So pre-processing dot label encoder. This is the label encoder. have to create the object for it. So I'm storing the object in a variable called label underscore encoder again, like this, right? So now what we have to do, we have to convert all the object types that are the categorical types to the numerical types, right? So how it can convert it? So if there are two categories like manual and automatic in transmission attribute, I have to assign one value to manual and one value to automatic. For example, 0 to manual and 1 to categorical value automatic, right? So all the rows with manual transmission will have 0, and then automatic will have 1 as its corresponding value. Same for dealer and individual also. I can set 0 for dealer and 1 for individual. And for petrol it is 0, diesel 1 and CNG 2. Like that I can set the fuel type. Same goes for car name also. So this is how we assign the label encoders using this label encoder, right guys? So we'll create a function to convert each of these variables because it is repeated word, right? So we have to create a function label transformer, like that. I have to take the column name, data, and then column type, right guys? So I have to transform it here like this. I have to take the object label encoder dot fit transform like this, and we have to send the data of column name, right? So we have to store it in some variable, right? So instead of storing it in some variable, I will create a new variable in the dataset itself, right guys? So let's create a new variable, data of column name plus underscore encoded. So that variable name underscore encoded is my new variable after encoding, right guys? Let's run it. So we have to call this function and again for object type. So I missed it again here. We have to apply it for only object type, right guys? So if column type is equal to object type, then only we can do this, right? So we have to call this function again for I in car data dot columns again. We have to call this label transformer and send the column name that is nothing but I, and data that is nothing but the car data, and then at last the type, car data of I dot d type. This is how we do it, right guys? So after this, let's print the car dataset dot head. Let's see few rows. Oh, okay, I remove one comma. So this is how we encoded the values. So for car name, you see car name encoded. For fuel type, it is fuel type encoded, and for seller type, it is seller type encoded. For transmission, it is transmission encoded. So you can ask me, I cannot see whether 2 is corresponding to which value and 36 is corresponding to which value in the car name. So we can do that. Let's see. Let's take these two variables, car name and car name encoded. Car data dot car name dot unique, right? And then let's run it first, and then car data dot car name encoded dot unique. Let's run it. So if you observe here, this will be having the same number of values as this, right? Let's take the shape also here again, comma dot shape, right? Dot shape 44. So let's take this one also, the encoded one, and let's take the shape. So if you see 44, so Rich is corresponding to 36 and SX4 is nothing but 39. And in the similar way we can do for fuel type also. So we have to take fuel type and fuel type encoded. If you see petrol it is 2, diesel it is 1, and CNG it is 0, right? 3 values. Same thing goes for seller type and transmission encoded. While creating the web app, these values will be more helpful, right? Dealer is 0, individual is 1. And for transmission, so manual it is 1, automatic it is 0. Right guys, this is how it converted the categorical values to numerical values. So now it's time for us to extract the features, and we have to make it an X column and take the selling price as Y column. Let's do this. So I took X data as like this, car data dataset of present price, KMS event, owner, year, car name encoded, fuel type encoded, seller type encoded, transmission encoded. So these are my X data. So what will be my Y data again? Y data is nothing but only the selling price, right? Selling price, like that. Let's run it. So if you want to see the data, X dot head, this is how it looks. All are numerical type. So Y dot head. So this is the selling price. If you want to see the shape, X dot shape, comma Y dot shape. So if you see 299 of 8 features and 299 of 1 feature, which are we going to predict. Now let's pair plot these X, our feature variables, along with our selling price using C1, right? SNS dot pair plot of PD dot concat of capital X, comma capital Y, and we have to mention the axis also is equal to 1, and then close it. So it will show us the pair plot for each and every variable along with the selling price also. So these are the pair plots for each and every variable, right guys? So if you see here, present price, kilometers driven, owner, year, and at last the selling price. Selling price against all other variables you can see here itself. Selling price versus present price. Selling price versus kilometers driven. Owner versus selling price, right? So if you see, the owner is the first owner, then the price is maybe higher than the second hand car, right? And then the manufacture date is closer to the current date, then the price may increase like this. See, for 2005 it is here, and 2015 it is higher selling price, right guys? So based on the brand name also, the selling price may be vary. And the fuel type, if you observe, see, for 1 it is higher, and then for 2 it is okay, and then for 0 it is very less. And seller type, for 0 it is higher than 1. So what is 0 for seller price? So 0 is dealer. For dealer it is more than individual, right? For petrol and diesel cars, the demand is high, the selling price is high. So like that we can get the analysis from these graphs. So now let's go ahead and split our data into training and testing datasets, right guys? So to split the data, I'm using train test split from sklearn again. So from sklearn dot model selection import train test split, like that, and I can do train test split of x comma y, and test size. I have to give the test size of maybe 0.1 because we have only less data of 299 rows. I'm giving it as 0.1. So 1% data I'm taking for testing, and random state as 1. Okay, so it makes sure whenever we run this code again, the same rows will go for testing and same rows will go for training. So from this train test split we'll get x train comma x test comma y train comma y test. So these are the datasets we'll get it from this train test split, right? So let's print the size of each and every dataset again. X train dot shape, like that. So let me change them quickly. X test, y train, y test. So if you observe this, 269 goes for training of 8 features and 30 is for testing, right? Same goes for y dataset also. Now let's import the linear regression model, right guys? If you see all of them, based on the variables, they are increasing, the kilometers driven is increasing, some of the selling price is increasing, the present price increasing, the selling price also increasing, right? Let's try linear regression model now. From sklearn dot linear model import linear regression, right? From, I want to measure the accuracy also, so let's import auto score again. Sklearn dot metrics import auto score, right? So let's run it. How to create the object for linear regression again? Linear regression, this is the variable I'm storing. Linear regression, I'm storing the object. Let's fit the model. Linear regression dot fit using x train comma y train, right? And we have to predict the x test, right? So linear regression, let's say predictions. I'm storing the predictions in this variable. Linear regression dot predict of x test, right? So it will give me the y predictions. And then linear regression, I have to calculate the accuracy rate. R to score and R to score of y test, and the predictions just we have done, right? After running this, let me print the accuracy here. So if you see, the accuracy is 91%, so it is higher than 90%, right? So let's see the data again. So y test, so these are the values for y test. So 0.38 is nothing but 38,000, 10.11 is nothing but 10,11,000, like that. We can take the values like this, and we can also print the linear regression predictions we got. So here are the predictions. I'm using zip to see the predictions and actual values side by side. So if you observe, few of them are not correct, like this, -1, -0.93, but 90% of the data will be accurate, because if you see here, the R2 score, it is 91, right? So if you see here, 1.15, actual value, it is 1.39, the predicted value, 1.15 and 1.40. So 4.9, it is 6.5, right? And 8.35, it is 7.8. And here it is 1.2, and here it is 1.9, right? Like that, it has given the values for our predictions, right? It has 90% accuracy. The same way, let's do for lasso regression, right? For lasso regression also, I will do the same thing. I have to import it from linear model again, lasso, right? And I can copy paste the same thing, but instead of linear, I have to give it as lasso. So let's do it. So I'm creating the object here, fitting the model here, and creating the X test data, and using the R2 score to find the accuracy. Right? Let's run it. Let's see the accuracy now. So it is 88% accurate. So not better than our linear regression model. And if you want to see the predictions, you can do the same thing. Linear regression, lasso regression predictions. We have to replace it. So 18, it is 12, 0.52, it is negative here, and 1.95, it is 1.34. Like that, it is giving the values. Let's test with one another last model, that is ridge regression, right? Ridge. Let's run it. Same thing goes for ridge also. Alright, DG, ridge. So let's run it. Let's see the auto score first. So it is 91% again. Let's see the predictions, how it got predicted. So if you see here, 1.95, it is 1.28, and 23.5, it is 20.11, right? Not bad. 7.5, it is 7.4. It is predicting pretty much good. So these are our predictions went on, and we had the better models as ridge regression and linear regression, right? So let's save this linear regression model first and try to create our web app, right? That's the main part where we have to give values from the UI, and we'll get the output when we click on predict button, right? Let's store this model using pickle, right? So I have to import pickle, yes, pickle, and then pickle dot, we have to use dump to dump our linear regression model in a file, right? I'm naming it as linear regression model dot pkl, right? Comma, using binary we have to open it. Like that we have to dump it. Yeah, it is pickle. Okay. So whenever I run this, you see a pickle model got created. You have to do the same thing. You have to run this notebook and get this pickle model file created. Then only we can use it in our web app, right? So let me show you the output of our web app, how it looks, right? So this is the output, guys. After showing you this output, I will show you how I created this streamline application, right? So these are the car brands, guys. Reds, Wagoner, and Shift, Alto. Every attribute, every category we got in our dataset is listed here. Fortuner. Like that, we have to select any of that value. And the manufacturer years. This is also in the range of our dataset, guys, 2007 to 2014, right? Let me select a year, 2009. And number of kilometers driven, guys. So if you observe this, 500 to 5 lakhs. Let's take it as 1,20,000, something like that, 21,000. Let's take it as petrol only. Fuel type and seller type is a dealer, and transmission type is manual. And the owner, it is the first owner. So let's take the current present price as 4 lakhs, guys, and then predict it. So if you see the predicted selling car price is around 64,315, right, guys? So if you see here, we can change the year to 2010. Then it is the latest car, right? Better than 2009. Then it should be 1 lakh, right? And if it is 2011, then it should be more than 1 lakh, right? 1,49,000, like that. So if it is less kilometers driven, it should be 1,63,000, right, guys? So if it is more kilometers driven, then the test price should be less, right? So 67,000, because it is driven, it is used many times, right? So that's why the price is fluctuating like that. So based on these values, we can predict our selling car price here. So let me show you how we created this web app, right? So let me show you that. So I have opened the VS Code here. Let me create a file here called app.py. So in this app.py, we have to import the required libraries like numpy, import numpy, yes, np, and import the pickle again. So because, let me change the environment, base. This is how we change the environment also. So import pickle, yes, pkl, right, and import streamlit, yes, st, right, guys? So pickle is to import our data model, the machine learning model, right? So let me import that model equal to pkl dot open of. You have to give the same model name, linear regression model dot pkl, right? We have to read it as binary, as we stored as binary wb, we have to read it as rb, read binary, right? After opening the file, we have to load it, right? There we have dumped it already, so we have to load it. There is load function here. we can do like this: load of open this file, right? This is how we load the model into our variable. Now let us put the heading for our app. If you see here, we have to use st dot header and then give our title: car price prediction linear regression model. So I'm giving it a linear regression model, right? So let's save it. Let's see how our app runs, right? To run this app, let me show you the heading first. So to run this app, you have to give python fnm streamlit run app.py, right? So if you see here, we can only see the title, right? Now we have to create all of them. As you seen in the earlier output, we have to create all the sliders, select box, everything, right? Let's create them. So I'm creating a select box to select all the car brands, right? The first input is car name, right? So you have to create st dot select box, and then I have to give our input like select. This is like a placeholder select title to our select box. So select car brand. So which car brand you want to select it, and we have to give our data here. But where can we get this data? You know, we get this data from our dataset, right? So we have to import our dataset, obviously. Car data again equal to pd dot read underscore csv. We have to import pd also. That is nothing but pandas. Import pandas as pd, right? And then we read our car space data dot csv, right guys? And then we know that car data will have more number of car names, but we sorted out them using our brand lambda function, right? The same brand lambda function I will create here, lambda x dot split. I will split that space and I will take the first value, right? After creating this, I will overwrite the car name column, right? So car underscore name column capital N, and I will overwrite this dot apply of brand, right? This is how I overwrite this column. Then I got all the car name values. I will mention here car name of car name column dot unique. So this is how we get all the unique car names. Let's save it and see here. So let's refresh it. You see, select car brand. You see all the car values here. So we can select any of them, right? Now let's go on. Now we have to select the year, right? So for year, I have slider bar, right? Slider car manufactured date of the car, right? Manufactured year of car, right? And I can simply do that 2007 to 2014 because I know the minimum and maximum value of a dataset from that statistics. We got it earlier. We can do this, right? So after saving it, let's check. After refresh, you see we got the slider, right? In the same way, let's do for other variables also. So next is kilometers driven. I can do the same thing for kilometers driven. Instead of years, I have to view the kilometers, 500 to 5 lakhs. And then I have to give the fuel type. So it will be again the select box, right? Copy paste it, select fuel type, right? Here instead of this, fuel underscore type, capital T. The same thing goes again for select type, right? Select type, select type. One more time, that is for transmission type. Transmission, right? Like that. And then for owner also we have different, right? 0, 1, 2, like that. So select owner, like that. Now at last we have to set the present price of the car, right? The present price is nothing but the integer value, so I am taking the slider. So let me take from 30,000 to 10 lakhs, right? Now after giving all these values, let's see how it looks. So if you see here, manufacturer. Oh, okay, I have to change the headings also. Present price of the car, right? I've changed for everything except this. Again, this is kilometers. Save it. Let's see now. So present price of the car, here it is. Select owner 0, 1, 3. There are only 3 types. And then dealer, individual or dealer, manual or automatic, and then petrol, diesel, CNG, and number of kilometers driven, manufacturer of the car, and then car brand. We have all these attributes. But if you observe, these are the categorical values again. We have to store them and pre-process all these values and use it to predict the seller price, right? So let's do that. We have to store all of these values first. So car name as car name, and again manufacturer year as year, and then kilometers driven is nothing but kms driven, like that. And then the fuel type, okay. And then the seller type, transmission type, okay. I can give transmission alone, transmission, right? And then the owner, lost, present, price, right? So this is how I am taking the inputs, and let's say I created a button st dot button of predict, right? So if I click on this button, it will return true value. So I know that it is true value. So if this is clicked, I have to create a data frame and send it to, I have to create the X text data, right? That is nothing but a data frame again with test data values of one row. So here it is only one row, right? Because at a time I can give only one row, right? So let's create it pt dot data frame of, I can give the data here. So in the same way how we took the inputs in the training data set, the same way we have to send the X test data set also in the same order also. Present price, chemistry driven, owner, year, car name, fuel type, seller price, seller type, and then transmission, right? And we have to set the columns also. Let me do that. So comma columns. So these are the columns I took, and we have to modify each of the columns when there is some categorical values, right? Let me do that. But before that we have to store this model, right? Let me do that. So X test data, you can say it is X test, right? So if you see here, the fuel type encoded, I am replacing all the categorical values. Like if it is petrol, it will be replaced with 2. If it is diesel, it will be replaced with 1. If it is CNG, it will be replaced with 0. So as we seen earlier here, like let me show you. So if you observe this, the corresponding value for petrol it is 2, diesel it is 1, CNG it is 0. So I took the same values from here, copy pasted using that replace function, right? Same for dealers, individuals 0 1. Same for manual, automatic it is 1 0. And same for car names also here. They are different values, right? Same way I copy pasted all of these values here in the replace function, and I took in place equals to true, so it will do the changes in the same dataset itself, right? Same for car name also, I took all the information from the Jupyter notebook, right? We can do the same thing. Then there is one lost variable we have to modify, because you see the present price is in 30,000 to 10,000 values, but what we have to do is we have to convert them to points, right? 0 point something like that, right? Because that is how the dataset looks. If you see, observe here, present price it is 5.59, 5 lakhs for 59,000, like that it is there. So what can we do is we can divide this with 1 lakh, right? So 1 lakh is 1.0, right? 1.0, 1 lakh 30,000 is nothing but 1.3, like that we have to do that. So let me do X test of present price is equal to the same thing I have to paste here. Along with that we have to divide it by 1 lakh. But I can also do this, we can also multiply it with 10 power minus 5, right? Same thing. So I'm multiplying it with 10 power minus 5. So 10 power 5 is nothing but, after 1, 5 zeros is 1 lakh. So the value divided by 1 lakh, I took 1 lakh to numerator, and it becomes 10 power minus 5, right? Now let's predict using the model, right? So model dot of X text, right? X test data. Now let me store this in selling price predicted, selling price predicted, and I can use a markdown here again. Markdown, this HTML tag, we can write HTML tags also in this markdown. So I took a paragraph tag here with font size of 20 pixels, and I've written it predicted selling car prices around in that paragraph tag, right? It will be of font size 20 pixels. And then I took one more paragraph tag where I took font size as 20 pixels and color as sky blue. So to differentiate between that line and the only predicted value, I did this, and I rounded off our price values to 2 decimals and printing it. So we have to use this unsafe allow HTML equal to true to allow our markdown to write these HTML tags, right? Let's save it. Let's go to our app again. Here it is. Let's refresh it. Now let's try to print it again. So let me take Fortuner 2009, kilometers driven, petrol dealer, let it be manual, and present price of the car, let me take 4,52,000 and then predict. So it will be 73,570 rupees. The predicted selling car price is around 73,570, right? Now let me increment this here. It will be increasing, right? 1,16,000, right? Let me increment further. It will be increasing, 1,58,000, right? Let me increment this also. It will be decreasing again, 1,26,000, because car is being used for more number of kilometers, right? So it is used many times. So based on these values, it is predicting the car price. This is how we made this project on web app. So guys, we are around 1k subscribers, near to 1k subscribers. Please subscribe and share this channel to your friends who are interested to learn machine learning in 2025, and please support us. Thank you. Thanks for watching. Stay tuned for other videos also.